In our previous lesson, we learned to find perimeter and area of rectilinear figures. In our daily life, you also come across various objects of circular shapes. For example, a bangle, an earring, a circular table top, a saucer and many other objects. Here is a circular object with a circular rim. How can we find perimeter or area of this circular object? We can use the scale to find out the diameter of this circular object, but can we use the scale to find out the perimeter? No, we cannot. So, let us use this thread to find out its perimeter. We wind this thread around the rim of the circular object. Let us measure this thread on the scale. This is coming out approximately 17.5. So, this is the perimeter of the circular object. The perimeter of a circle is called its circumference, but this method does not always give us accurate result, maybe due to personal or instrumental fault. In our previous classes, we have learned that the ratio of the circumference of a circle to that of its diameter is always same irrespective of the size of the circle. So, if this is the circumference of the circle, its ratio to that of its diameter of the circle is always same, and we denote it by a Greek letter pi. It is an irrational number and its value is approximately equal to 3.14 or 22/7. So, if we write circumference of the circle as c and the diameter of a circle of radius r as d, then c/d is equal to pi, but we know that diameter is equal to 2 times the radius. This implies that c is equal to, I can take diameter to the right hand side. So, this will be 2 times r multiplied by pi or 2 pi r. So, what is the circumference of a circle? The circumference of a circle is equal to 2 pi r, where r is the radius of the circle. Let us see how we can use this result to solve this problem. The problem is, a boy is cycling such that the wheels of the cycle are making 140 revolutions per minute. If the diameter of the wheel is 60 centimeter, find the speed with which the boy is cycling. Suppose this is the wheel of the cycle. Since its diameter is given as 60 centimeter, so its radius will be equal to 30 centimeter. The distance covered by the wheel in taking one revolution will be nothing but the circumference of the circle. So, the distance covered in one revolution will be equal to 2 times, circumference is 2 pi r. So, 2 times 22/7, taking pi as 22/7 into radius is 30 centimeter. So, this is the distance covered by the wheel in one revolution. So, the distance covered by this wheel in 140 revolutions will be equal to 2 multiplied by 22/7 into 30, that is the distance in one revolution multiplied by 140. So, that gives us 26,400 centimeter. This is the distance travelled or distance covered by the wheel in 140 revolutions. but this 140 revolutions the wheel is covering in 1 minute. So, the speed of the wheel is equal to 26,400 centimeter per minute, but we have to find out the speed of the wheel in kilometers per hour. So, speed of the wheel in kilometers per hour is equal to 26,400, this is in centimeters. First of all, we have to change it to kilometers. So, divided by 1 lakh. So, this number is now in kilometers, this quantity, and we have to change from minutes to hours. So, 1 minute 60 minutes gives us 1 hour. So, this is the actual quantity, 26,400 divided by 1 lakh multiplied by 60. So, the speed is 15.84 kilometers per hour. But how can we find out area of a circle? This is a circle, we have to find out its area. If we divide this into a number of sectors and we cut them like this is one sector, and arrange them in this order, then what shape do we get here? This is nearly a rectangle, but it is not exactly a rectangle. But if the number of sectors are increased, then we almost get a rectangle whose length is nothing but half the circumference of the circle and whose breadth is the radius of the circle. So, area of this rectangle will be equal to half the circumference of the circle is pi r, because 2 pi r is the total circumference. So, half of it will be pi r multiplied by the radius of the circle is r, that is equal to pi r square. Therefore, the area of this circle will also be equal to pi r square. So, what is area of a circle? Area of a circle is equal to pi r square units, where r is the radius of the circle. Let us again see how we can use this formula for finding out the area of a circle in solving few problems. Here is a problem. The radius of a circular garden is 100 meters. There is a road 10 meters wide all around it. Find the area of the road and the cost of leveling it at rupees 2 per square meter. So, suppose this is a circular road. The width of this road, this width is 10 meters and the radius of the inner circle is 100 meters. This garden, radius of this garden is 100 meters. We have to find out the area of this road. How can we do it? Area of this road will be equal to area of this outer circle minus area of this inner circle. Now, area of this outer circle is, suppose we take the radius of this outer circle from 0 to, suppose this is A, point A. So, radius of this outer circle we represent by capital R, and the radius of the inner circles we suppose write it as OB, OB as small r. Then this area of the road will be area of the outer circle, that is pi capital R square, minus area of the smaller circle, that is pi small r square. Now, what is capital R? Capital R is 100 plus 10, because the radius of the garden was 100 meters. So, 100 plus 10 pi into 110 square minus, we have to find out area of the inner circle, its radius is 100 meters. So, pi into 100 square. We can take out pi common or put the value of pi as 22 upon 7. Taking it out common, we are left with 110 square minus 100 square. We can use the formula a square minus b square here, and what is that formula? It is a plus b into a minus b. So, using that formula here, what do we get? Let us see, we get 22 upon 7 multiplied by 110 plus 100 into 110 minus 100. This is equal to 22 over 7 multiplied by 110 plus 100 is 210, multiplied by 110 minus 100 is 10. Solving this, we get area of the road as equal to, this gets cancelled, as 6600 meter square. So, this is the area of the road. Now, we have to find out the cost of leveling the road at the rate of 2 rupees per square meter. The total area of the road is 6600 meter square. So, total cost of leveling the road will be rupees 6600 multiplied by 2 rupees per square meter, which is equal to rupees 13,200. So, this is the total cost of leveling the road. Now, you have learned that circumference of a circle is equal to 2 pi r and area of a circle is equal to pi r square. Now, suppose we are given this semicircle, how can you find out the length of this arc, which is making an angle of 180 degree at the center? Since this is a semicircle, therefore, this is its length will be half the circumference of the circle. So, area length of this arc, if I mark this arc as AB, length of the arc AB is equal to half 2 pi r. So, what will be the length of this arc, which is making an angle of 90 degree at the center? Again, since this is quarter of a whole circle making an angle of 90 degree at the center, therefore, its length of this arc will be 1/4 of the circumference of this circle. So, length of the arc AB, if I mark this arc as AB here, is equal to 1 upon 4 2 pi r. Can you tell what will be the length of this arc AB, which is making an angle of 60 degree at the center? Think what part of the whole circle is this arc. The total angle subtended by the whole circle at the center is equal to 360 degree, and this arc AB is subtending an angle of 60 degree at the center O. That means, the arc AB is 1/6 of the whole circle. So, length of the arc AB will be equal to 1/6 of the circumference, or I can write it as 60 degree upon 360 degree into 2 pi r. In general, if an arc is subtending an angle of theta at the center of a circle, then its length will be equal to 2 pi r into theta upon 360 degree. Let us see how we can use this result in solving this problem. The problem is, find the perimeter of the sector of a circle of radius 6 centimeter making an angle of 60 degree at the center. So, this is the circle. We have to find out the perimeter of this sector, which is making an angle of 60 degree at the center. Perimeter, as you very well know, is the sum of the length of all the sides of the figure. So, perimeter of this sector will be equal to length of this arc plus the sum of these two radii. Therefore, we can write perimeter of the sector OAB is equal to length of the arc AB plus the length of the radii OA and OB. Now, we know how to find out length of an arc which is making an angle of theta at the center. Now, in this particular case, this sector is making an angle of 60 degree at the center. So, the length of the arc AB will be equal to 2, let us take pi as 22 upon 7, 2 pi into r is 6 into theta in this case is 60 degree upon 360 degree plus the length of the two radii is 6 plus 6, which is equal to 12. What do we get? We get here this is 44 upon 7 plus 12, which is equal to 6.28 plus 12, which is nothing but equal to 18.28 centimeters. So, the perimeter of this sector is equal to 18.28 centimeters. We have learned that area of the circle is pi r square whose radius is r. So, can you tell what will be the area of this sector AOB, which is making an angle of 180 degree at the center? Since this is a semicircle or half of the circle, therefore, the area of the sector AOB will be equal to half pi r square, is not that so? Similarly, can you tell what will be the area of this sector AOB? Again, since this sector is making an angle of 90 degree at the center, therefore, this is 1/4 of the whole circle and hence its area will be equal to 1/4 into pi r square. Now, can you tell what will be the area of this sector AOB, which is making an angle of 60 degree at the center? Again, think what part is it of the whole circle? By the previous arguments, we can say that since the whole circle is making an angle of 360 degree at the center and this sector AOB is making an angle of 60 degree at the center, therefore, area of this sector will be 1/6 of the area of the whole circle. Thus, we can say area of the sector AOB is 1/6 of the whole area of the whole circle, that is pi r square. Otherwise, we can write it as 60 degree upon 360 degree into pi r square. In general, if a sector is making an angle of theta at the center of a circle, then the area of that sector will be pi r square theta upon 360 degree. Let us again see how we can use this result. See the problem. The length of the minute hand of a clock is 9 centimeter. Find the area swept by the minute hand if it moves from 6 a.m. to 6:35 a.m. Now, here is the clock, and suppose this is the minute hand of the clock. The minute hand starts moving from here. At 6 o'clock the minute hand will be at 12, and at 6:35 the minute hand has moved from this, it has swept this area and reached here at 7. So, what is the angle made by this minute hand? We have to find out the area swept by the minute hand. In order to do that, we need to find out the angle made by the minute hand at the center. Now, we know that in 1 hour a minute hand makes an angle of 360 degree, because it starts moving from 12 and again reaches 12. So, in one full circle it is making an angle of 360 degree. So, what will be the angle made by this minute hand in 1 minute? In 1 minute the angle made by this minute hand will be 360 degree upon 60 degree, that is equal to 6 degree. So, in 1 minute the minute hand moves an angle of 6 degree. So, how much angle will be made at the center of the circle if this minute hand moves from 12 to 7? That means it moves for 35 minutes. So, in 35 minutes angle made by this minute hand will be equal to 6 degree, that is angle made in 1 minute multiplied by 35, and we get that is equal to 210 degree. So, this minute hand is making an angle of 210 degree at the center of the circle, and now the problem becomes easy. You have to find out the area swept by the minute hand. We know the formula. What is that formula? It is pi r square into theta upon 360. Theta we have already found out, it is 210 degree. So, the area swept by the minute hand is equal to, let us take pi as 22 upon 7, pi into r square, r is 9 centimeter. So, 9 into 9 into theta, that is 210 degree upon 360 degree. And what do we get after solving this? This is equal to 297 upon 2, which is equal to 148.5. Now, look at this circle. What is this chord doing? This chord is dividing this whole circle into 2 segments. One is segment ACB, and this is the minor segment, and another is the segment BDA, that is the major segment. Suppose we want to find out the area of this minor segment. How do we do it? We join this A and B to the center of the circle, or we draw the radius of the circle. Let them be equal to r each. And let us suppose that the angle made at the center is equal to theta. Now, this is the figure. We have to find out the area of the segment ACB. The area of this segment ACB is now equal to area of the sector AOB minus area of the triangle OAB, area of the triangle OAB. Now, if r is the radius of the circle and angle theta is angle made by this sector is theta at the center, then we know how to find out area of a sector. Area of this sector, we are finding out area of the segment. Area of segment ACB is equal to now area of the sector AOB. What is that? It is pi r square into theta upon 360 degree minus area of the triangle OAB. And what is that area? Area of the triangle OAB when the vertical angle is theta and it is an isosceles triangle with two sides equal to r is equal to half r square sin theta. The derivation of this formula you can do in higher classes. So, this is the actual way to find out area of the minor segment ACB. So, what is area of a segment ACB? Area of a segment is equal to pi r square theta upon 360 degree minus half r square sin theta, where theta is the angle made by the segment at the center and r is the radius of the circle. Let us use this formula to solve this problem. Here is the problem. A chord of a circle of radius 15 centimeter makes an angle of 60 degree at the center of the circle. Find the area of the minor segment, and we have to take pi is equal to 22 upon 7. So, suppose this is the circle and this is the chord AB. We have to find out the area of the segment ACB. Again, we follow the same rule. We join OA and OB. The radius of the circle is given to be 15 centimeter and the angle made at the center is 60 degree. Therefore, area of the segment ACB is equal to area of the sector AOB minus area of the triangle OAB. Now, area of the sector AOB is equal to pi into r square. I am writing down the formula first, upon 360 degree minus area of the triangle is half r square sin theta. Pi, we have been asked to take pi as 22 upon 7. So, pi into r square is 15 into 15, theta is 60 degree upon 360 minus half into again r square, that is 15 into 15 into sin 60 degree. Solving this part, this is equal to 825 upon 7 minus half 15 into 15, and the value of sin 60 degree is under root 3 upon 2.